All right, hello there, Bio 30. So at this point, you should be well into your excretion unit, and I'm going to be doing this lesson on homeostasis and the role of kidneys in maintaining homeostasis. Now, I'm going to trust that you can read the notes by yourself, but I'm going to be reviewing the feedback loops involved with ADH and aldosterone. All right, so let's just remember one of the kidney's function is essentially to filter the blood. But as part of this, they also play a large role in maintaining appropriate blood pressure and in making sure that we are hydrated and that our blood volume is appropriate and maintaining our body's water balance with osmoregulation. Now, because of this, so remember the nephron plays a large role in controlling the amount of water that is released in our urine. And these hormones play a role in changing the amount of water reabsorption in that process. All right, so I'm going to walk you through again. I'm going to trust that you can read this all, but this is just kind of a quick overview. Okay, so we're going to go through this feedback loop on page 25. All right, I'll read you the scenario and then we'll go through the boxes. A lost explorer stumbles over sand dunes as the searing midday sun beats down on him. He's lost his caravan during a huge sandstorm. With every breath and every drip of sweat, he loses precious water. His muscles begin to cramp. Dehydration is setting in. His blood volume falls and the amount of water in the blood decreases. This triggers the release of ADH, which increases water reabsorption in the distal tubule and the collecting ducts. Urine becomes more concentrated than the blood. As he crawls over a sand dune, he sees his caravan. Reunited with his caravan, the explorer rests under a tarp and refreshes himself with a large jug of water. His blood volume rises, and the amount of water in his blood increases. This triggers a decrease in ADH output. Reduced ADH makes the distal tubules and collecting ducts less permeable to water. Less water is reabsorbed, and urine is produced is more dilute than the blood. All right, so we have to fill in this feedback loop, and we're going to be working it through dehydration and hydration. Now, a lot of the kind of key things are actually in this paragraph, but I will review it as well. All right, so here we have it. I'm going to be using two different colors. I'm going to start with cause number 1, which is dehydration. Okay, so if we are dehydrated, the change that is occurring is we have low water levels in our blood. Okay, the sense of this is sensed in our osmoreceptors in our hypothalamus. So as the blood passes through the hypothalamus, the osmoreceptors sense the low levels in the blood. Our control center is going to kind of be a combination of our hypothalamus and our pituitary. So if you remember in the reading, the hypothalamus is responsible for producing ADH, and the pituitary kind of stores and releases that appropriately. So what's going to happen is if there is low levels of blood, the hypothalamus and pituitary are going to produce and release ADH, antidiuretic hormone. The effector, so where does this ADH go? What does it act on? It's going to mainly act on the distal tubule and collecting duct of the nephron. Sorry, I can't fit all my writing in the box. All right, so the ADH acts on the distal tubule and the collecting duct as the effector. What does that ADH do? What does it change? It's going to cause those tubules, whoops, it's not very clear. It's going to cause those tubules to be more permeable to water. Okay, so they're more permeable. What that means is that water is able to actually pass out of the tubules and back into the blood to be reabsorbed. So tubules are more permeable. Water is reabsorbed into blood. So it gets into the capillaries eventually. What that means then, sorry, lots of writing here. What that also means is that we would then have very concentrated urine. Sorry, that says concentrated. Okay. And what that then means is we are going to eventually return to properly hydrated. Okay. So we're probably still gonna have to drink some more water, but eventually we're going to kind of work at making sure we're not excreting extra water so that we can return to hydration. Okay, so summary, we're dehydrated. Therefore, we have low water levels in our blood. Our osmoreceptors in our hypothalamus in our brain sense this. That hypothalamus produces ADH, and then the pituitary gland will release it. That ADH hormone will have an effect on the distal and collecting duct of the nephron. Those tubules then, under the control of ADH, become more permeable to water, which means water can pass through and be reabsorbed into the blood. Therefore, our blood becomes kind of more hydrated and our urine is very concentrated because we are excreting very, very little water. Okay, all right, scenario 2. Now this one's going to be kind of quick because there's a lot of overlap. If we are properly hydrated, we would then have high to normal water levels in our blood. The osmoreceptors in our hypothalamus are going to sense that we have normal levels, okay? Our hypothalamus and our pituitary are still the control center, but because the osmoreceptors indicate that there's proper amounts of water, there's going to really be no release of ADH. The effectors are still the same, but because there is no release of ADH, that means the tubules are kind of left alone, and the tubules are naturally less permeable to water. So less permeable, which means water is not reabsorbed. So therefore the water is lost in our dilute urine. All right. But remember, we were properly hydrated, so us peeing out some of that extra water is okay. We should still remain still hydrated. All right, and if that were to change, then the ADH would kick in. Okay, now I would like to move on to the other hormone, aldosterone. Now let's keep in mind ADH and aldosterone, they kind of work together, all right? They're often released simultaneously, but aldosterone is more closely related to blood volume and blood pressure. All right, so here we're only doing one feedback loop where the cause is dehydration. Okay. Okay, if we are dehydrated, that would mean our blood volume is low and therefore we have low blood pressure. That low blood pressure is going to actually be sensed by receptors in our arterioles, mainly in the afferent arterioles in the kidney, okay? The control center here is going to be the adrenal gland. So remember, those adrenal glands are just on top of the kidney. So the receptors in the arterioles are going to sense that the blood pressure is low. That's going to trigger the adrenal gland to release aldosterone. Okay, so release the hormone aldosterone. Now, aldosterone, works a little bit differently. It is still going to be acting on the nephron as the effector, or more specifically, again, the distal, tubule, and collecting duct. Now, instead of changing permeability to water, what aldosterone is going to do is it's actually going to trigger these tubules to actively transport sodium into the blood. Okay, so it's going to work on actively transporting sodium. So what's going to happen here is those tubules are going to actively transport, which means it's going to require them some energy, sodium ions, okay, part of salt, into the blood, which will help with the reabsorption of water. So, and reabsorb water into blood. Okay, so essentially what happens is by actively transporting sodium into the blood essentially becomes hypertonic and the water will naturally follow through osmosis. All right. So therefore, because water is now entering into our blood volume is going to increase. So our blood volume and blood pressure will return to normal. And again, aldosterone and ADH kind of work hand in hand, and they both work together to do this. All right, there you have it.